Hello, good afternoon, everyone. My name is Aparupa. I'm a data scientist in Cisco. I work with the openstack team there. So today I'm going to talk about anomaly detection. It's a great way to leverage the vast amount of data that is generated in the openstack environment, and you can use it for proactively monitoring your infrastructure. So let's see what kind of data is being generated in the OpenStack environment. So you have logs, you have metrics. So what are these logs? The logs are basically lines of texts with timestamp. They are very unstructured. Examples of logs would be your system logs, your application logs, and so on and so forth. Example of anomaly in logs would be, suppose the frequency of error logs shoots up to an unusually high value. So that can be a scenario where an anomaly occurs in logs. On the other hand, you have metrics. So what are metrics? So these are basically time series. So you will have some numerical value which is changing over time. These are very structured data. Examples would be your CPU utilization changing over time, your disk latencies or utilization changing over time. All these are examples of metric data. An example of anomaly in metrics would be, suppose the disk read-write latency shoots up to an unusually high value. That is a scenario where an anomaly has occurred. Usually, logs are used a lot more for monitoring for root cause analysis than metrics data, which are fairly underutilized. So moving on, how do we do anomaly detection on logs and metrics data? So one approach is to convert logs to metrics. So you can group similar logs, and for each group of similar logs, you can generate a time series or metric. And this metric can be a frequency of logs that are appearing in consecutive intervals of time. So once you reduce the entire data space to metrics, you can then apply all the sophisticated techniques of anomaly detection on time series on these metric data and build your anomaly detection system. So the remaining talk is basically going to be about anomaly detection for metric data. So I'm going to tell you some of the patterns that are observed in metric data. So you'll observe trends where there's a long-term increase or decrease in the data. You will also observe seasonal patterns, which is basically a repetition of a pattern for a fixed known period of time. So it can be a weekly pattern, which means after every 7 days, the pattern of data repeats itself. Another kind of pattern that is seen in metric data is cyclic patterns, where the data repeats itself over time, but we don't know the fixed period after which it's going to repeat itself. I'm going to show you some examples here of how metric data can look like. So on top left, you have metric data, which is basically exhibiting seasonality and cyclic behavior. Top right, you can see trend in the metric data. And below, on the left, you can see metric data, which is exhibiting trend and seasonality. And finally, we have a data which is totally random. So you can well imagine how hard it is to come up with an anomaly detection method, which is going to identify an anomaly on such a diverse set of metric data. So basically, we always apply a two-step approach for anomaly detection in case of metrics. The first step is to identify a baseline. So by baseline, I mean you have to define what a normal behavior of your data is. And the next step is, once you define what is the normal behavior of your data, the next thing that you have to do is compare your data with the normal behavior. And if there's a deviation from the normal behavior, then you raise an anomaly. So I have a simple example over here. You have a metric which is changing over time. So for anomaly detection, I have to follow the two steps that I mentioned earlier. So step one is I have to define what is the normal behavior. So if I define the normal behavior as anything which lies 3 standard deviations above the mean and 3 standard deviations below the mean is normal, and anything lying outside this range is anomalous, then if I apply this, then all the points that you see here, which are above the upper safe region, are actually going to be identified as anomalous data points. As far as, so the method that I just mentioned just now, it falls in the category of statistical quality control-based methods. Now, you can well imagine, since there are such a diverse set of metric data available out there, there is a diverse set of methods available out there for anomaly detection. So how do you find out which method is going to work best for your data? So there are 3 things to keep in mind. First thing is you have to understand the nature of your data. Does your data exhibit seasonality? Is it normally distributed? These are things which you have to understand about your data. Secondly, you have to understand the nature of anomaly in your data. What does anomaly look like in your data? Is it a point anomaly? Is it a contextual anomaly? And finally, you have to understand the strengths and limitations of the anomaly detection method. For example, your data might not be normally distributed, but the method requires that the data should be normally distributed. Or it might happen that your data shows seasonality, but the method ignores seasonality. And finally, it might be that you have found a method which works well for your data, but it's not scalable. So all these 3 factors are important to identify what is the best anomaly detection method for your data. Finally, I'm going to conclude this talk with a use case of anomaly detection. So this is a beautiful dashboard that has been built by one of my colleagues at Cisco, Kai Zhang. He's a software engineer. He has open sourced this dashboard for monitoring the Ceph storage clusters. And I'm showing you a snapshot here of the anomaly detection feature, which we are working on right now. We want to add this feature to this dashboard. And what I'm showing you right now is basically we are looking at all the metrics that are being generated by the OSDs and running anomaly detection algorithm on that and showing you how many of the metrics associated with a given OSD are anomalous. So in this snapshot, you can see that OSD1 is showing 1% of anomalous metrics, which means that if there are around 100 metrics associated with OSD1, then 1 out of those 100 is showing anomaly. And further, you can also zoom in and see exactly which metric is showing the anomalous behavior. So that's pretty much all that I have to present today. So thanks a lot for attending this presentation. I hope you enjoyed it. Have a good day. Thank you.